Hey everyone. In this video, I'm going to continue talking about data visualization. Specifically, I'm following along with the second half of the data visualization part 2 lesson on the website, so you can check that out for a little more information. But the things I'm going to go over today are how to combine multiple ggplots into sort of a single aggregate plot object, talk about how to save plots as either PNGs or JPEGs onto your computer. Both of these steps are pretty useful when you're getting into the more like publication or wanting to share your plots with others kind of stage of your research. And also a little bit about interactive plots and when they can be useful. So we can get started. I'm going to go ahead and load in the tidyverse, which is, so that we can get ggplot loaded into our RStudio library. And then to compile a few different plots, I'm going to go ahead and just make some plots kind of at random, just to sort of get in the practice of that. And if you remember last week, we brought up that there are some of these built-in data sets in R. I think we used the iris data set. And so I'm going to play, instead of loading in our surveys data, I'm just going to play with some of these built-in data sets as a way of saying, like, look, we can generate plots really without doing much in R. And some of those really popular data sets are diamonds, iris, and MPG. So we can take a look at those just to learn a little about them. So this diamonds data set, we can use the summary function with diamonds inside it just to sort of take a look at what this data set's about. And it looks like characteristics of diamonds, so carat, cut, color, clarity, etc. We used the iris data set a little while ago, but that has things like sepal length, width, petal width, and species. So a pretty straightforward data set. And also the MPG data set is about cars. So some manufacturer data with models, things like years, cycles, maybe highway mileage, this sort of thing. So we can generate a few plots just kind of playing with these data. So let's make a plot called diamonds plot. And remember, so last week when we were plotting, we were really specifying every argument, this data equals, mapping equals. But remember, we don't have to specify the argument first. We can just sort of put what's on the right side of the equal sign. So I'm going to go ahead and do that for this plotting exercise where our data equals diamonds, but I'm just going to write diamonds, comma, and our mapping equals aesthetic, but I'm just going to write AES and open parentheses. And let's go ahead and make a bar graph using a geom_bar, which we didn't get to last week. And so in bar graphs, you can often, this is one of the graphs where you actually don't need an X and a Y. What the default in ggplot is that if you provide it with just an X attribute, it will actually just use the count as the Y variable. So we can sort of practice doing that, where if we just say, for instance, that X in our diamonds data is going to equal clarity, it's going to count up the observations with different clarities. But let's also practice something else we didn't do last week, or I mentioned this idea of fill versus color as an argument, where color in some geoms will color something in, but in other geoms will only provide an outline. And geom_bar is one of those that will only outline if you use this color argument. So instead, we're going to use this fill argument where fill is going to equal diamond cut. So we want to basically color by diamond cut. And then we can do our plus sign, do a geom_bar without much else. And let's just play around with our themes. Remember, we talked that there are sort of a lot of different theme options out there. And let's just say we're going to do, what is it? Axis. Let's do axis text X. So we want to manipulate something on our X axis. And we're going to do this equals, and then element text is often the call on the right-hand side of anything that you're doing with text on the left-hand side. So we have an argument about text, then we want to answer it with this element_text function. And let's say angle equals 45 so that we basically rotate our axis text a little bit and just see what that looks like. So we have a diamonds plot. And let's see. Yeah, we expect a bar plot. where see our Y has just defaulted to count. We've filled by cut and we've rotated our X-axis text. It might actually be good to do a second call inside this element underscore text and write vjust, which is a vertical adjustment, because you can sort of see that when it rotates on an axis, it sort of runs into the plot itself, which isn't great. So if you play with these vertical adjustments, they're usually going to scale from 0 to 1. And if you do like vjust equals 0.5, you can move those labels down a little bit. Okay, so let's make another plot here where we're going to use the MPG plot equals ggplot open, and we're going to go straight into MPG comma AES. And then we're going to call upon maybe the city and highway variables as our X and Y. So again, we don't need to specify these, but we want to color by, say, I think this is cylinders actually. So let's say color equals, and we're going to make this a factor as cylinders, which we talked a little bit about last week. And then we want to make these some point data. So we're going to do geom underscore point. And we can play with also some new arguments inside the geoms for different sort of mappings. And we can say size equals 2.5. And we can call on this MPG plot and check out, yep, we have a scatter plot where we've colored by the factors of cylinders. I think this is actually city miles per gallon and this is highway miles per gallon. So you can see that relationship there. And let's make one more plot, call it iris plot. And assign iris plot with ggplot, jumping right into iris as the first argument, aesthetic. And then our X is going to equal sepal length. Our Y is going to equal petal length. So let's say we want to look at the relationship between sepal length and petal length. And we're going to, let's say we want to color or fill this by species. And then outside of our parentheses, we're going to do the plus sign. And on our next line, we're going to do another scatter plot. Or let's say we want to do alpha equals 0.3. And we can check that out. Our iris plot is maybe fill by species wasn't the best choice. Maybe because it's a geom point. I'm going to try color. And that's better. So you'll see with fill, that was really effective for a geom bar, but fill for a geom point actually doesn't go over so well, as it turns out. So those are things you just have to play with. But now we have 3 plots that, let's say for publication's sake, we actually wanted to put these all together and make them look nice. So that's where we're going to jump to the cowplot package. So remember, if you've never installed a package before, you'll want to do install.packages, open parentheses, and then confusing to remember, but when you're first installing, you'll want to put the package in quotation marks and there will be no auto completion because R has never heard of it before. So you'll have this line install.packages, parentheses, quotation, cowplot, and close both of those out. But then I'm going to hashtag that out because I've already done that. And then the next step is all I have to do is call upon library parentheses cowplot, and you can use quotation marks, but you no longer need to once it's in your R library. And there's just a couple of functions that we're going to learn in cowplot. And the first one is going to be plot underscore grid. So what happens is we've saved all of our ggplots into these ggplot objects now. And then we can call upon this plot underscore grid function within cowplot. And then we can pretty much just name all of the plots that we've just made. So I want to put in a grid this diamonds plot, comma, this iris plot, comma, and this MGB plot. And I think if we go ahead and do that without any additional arguments, I think that will still work just fine. So you'll see it'll populate in your, or it should populate in your plots tab. We can pop that out and say, cool. It has pretty much evenly divided up a box into kind of a small grid, and it's placed the 3 plots here. We could do a few more things with this, assuming, so you'll notice this kind of is a bit off with 3 plots, which we'll address in a moment, but before that, we'll say there are a few more arguments you can put inside of plot grid. This is something like a labels argument. So often in publications, you might want to be able to point to like figure 1A, figure 1B, figure 1C. And so you can do labels equals, and then you'll want to concatenate together. So remember that C function is often when we want to create a small vector of information in R. And so we say labels equals C, open parentheses, and then in quotation marks, you'll want to put the names of whatever labels you'll have. And the number of labels that you assign should be equal to the number of plots that you have. So R is going to look for a vector that has a length of 3 in that labels argument. And you can also specify if you wanted to switch this up, like I think we could do an n row and an n call argument, which would be the number of rows or the number of columns you want this grid to have. And we might be able to say n row equals 1. So you're saying, I don't really like these in this off kilter sort of grid. Why can you actually just put them all in a line for me? And let's see. I actually don't know. I'm looking at my pop-out window right now, which might not work with my screen share. So I'll go ahead and kind of make this adjustment and see if that is helpful at all, which it's not really adjusting super well. So yeah, something like this where you get your A, B, and C in a line. And you can, if you play with this zoom button in your RStudio viewer, these visuals can also pop out. But there, you might want to say, I do want there to be 2 rows, but I want one of the plots to take up more space in that row. And within that, we're going to introduce 2 different functions in cowplot. And this is going to be the ggdraw function, and then plus this draw underscore plot function. So it kind of uses this ggplot mentality of layering things on, which I'll show you just from the start. If you just start with ggdraw as an empty argument, you pretty much kind of like when we just started with ggplot as an empty function, you just get sort of a gray blank canvas. But what this is doing is sort of creating a canvas that you're going to specify where you want each plot to be in that blank canvas that also sort of has coordinates in a sense. So we'll do ggdraw open parentheses, leave it empty inside those. And then outside of the parentheses, do a plus sign, and we're going to layer on these draw underscore plot arguments. So draw underscore plot. And here, then we're going to specify each plot at a time and tell this draw plot function where in this sort of grid of ggdraw we want these objects to go. So draw underscore plot, we'll first write in our diamonds.plot. And then how we want to think of this draw plot blank canvas is that it's still like a plot that has an X and Y axis. It's kind of like a meta plot, actually. It's you're plotting your plots. And the x-axis goes from 0 to 1 and the y-axis goes from 0 to 1. So you can use x and y arguments in this draw plot function to specify where you want your plot to start and how much space you want it to take up. So to sort of get that through, we'll give this example, which is I want my first plot, my diamonds plot, to start at x equals 0. So this is I think the bottom. Well, so x equals 0 will be the leftmost side of the plot. And I'll also want it to start at y equals 0. And I'm going to want this to be iris plot, because this is going to be the bottom long plot that I'm going to try to specify. So I want this to start in the very bottom left-hand corner of the plot. And I want its width to actually take up the whole bottom portion of sort of this 3-panel plot. So the width is going to equal 1. So the whole x-axis is going to be taken up by iris plot, but the height is only going to equal 0.5 because I only want it to take up the bottom half of the plot. Then I'm going to close out this draw underscore plot function and do another plus sign and layer on another draw plot function. So each plot gets its own draw plot. So then I'll call upon draw underscore plot again. And then I'm going to be using this MPG plot. So now I'm going to say I want MPG, I think, to go, let's see. I want MPG plot, comma, and I want it to be at x equals 0. So I want it to be on the upper left-hand corner of the plot. So x is going to equal 0. It's going to be on the left-hand side, but y is going to equal 0.5 because I want it to start halfway up the y-axis. And then I want its height to equal 0.5 and its width to equal 0.5 because I only want it to take up half of the top row. And I can reverse those arguments, even though I wrote them with equals first in the previous drop plot. As long as I specify the arguments, I can put them in whatever order I want. So this should position, let's see, I can try to annotate this where Iris will take up the whole bottom of the plot, basically bottom row. MPG will take up top left. And then, so we can think a little bit about if we wanted the Iris plot to, or rather the diamonds plot to take up the top right. Might be good to kind of stop and think about how you would use these coordinates to do that. But what it's going to be is that you want X to equal 0.5 because you want it to start halfway across the X axis. You want Y to equal 0.5 because you want it to start halfway up the Y axis. And then you want the width and the height to also equal 0.5. This is a bit of a strange thing to get into, but it does, if you stare at it, it definitely makes sense. So diamonds is top right, or at least I hope it is. Let's see if I got all of this right. And it's unhappy with me. It says error, unexpected symbol in draw plot, diamonds plot. And then it shows me, this is a good thing for troubleshooting errors. It sort of stops me sometimes where it gets stopped. And so it says X equals 0.5 Y, and then it ends its error. And what that cues me into is R gets confused right around this point and out of practice. And like I've said to many of you, oftentimes just like a missing comma, a missing parentheses is sort of where most programmers go wrong. So I was missing a comma after that X equals 0.5. And so then it didn't know that there was going to be a new argument. And so it errored out. So now this should work. Okay. Yes. And so I think what happened was what I anticipated, where now the Iris plot is taking up the whole bottom because we specified that we want its width to be 1 across the whole bottom. And the two other plots kind of take up the top 2 of the first row. So this is a little bit labor intensive, but they're, you know, we could debate what kind of different packages exist to make this easier on you. So Tyler and I know both use grid arrange as a function, I think in the package grid extra. And there's also a package called patchwork that people seem to like. But generally, positioning your plots relative to each other does take some of this sort of coordinate specification, because otherwise they're, you know, the programs often aren't smart enough to sort of auto adjust based on what they think would be good for a human eye. So they're just going to divide plots up however they best can in a certain number of n row and n call, and you have to sort of manually tweak those if you want it to be a little easier. So how would we save this? Let's say I love this GGdraw sort of 3 plot thing that I just made, and I want to now put it into a paper I'm going to submit. You could start doing things like copying and pasting from this box, but maybe the more elegant way to do this is to, whatever your final plot objects are, save them as an object. So we could actually say, let's say this is like final plot object. And I save this 3 plot aggregate ggdraw as final.plot. And then I can use the function ggsave, which is just going to save plot images. So ggsave will open up. And the first argument and the main really only argument that you need in ggsave is a file name. So you need to specify a file path where you want this plot to be saved. And this sort of goes back to our earlier weeks where I feel like this is a thing that takes a while to get into the groove of, but if you remember the whole point of a project, your working directory that the project sets is always where your project lives. So we'll back up before ggsave, and you'll maybe recall this function that we used, getwd. And without any arguments, it will tell you in the console where you are in your computer, in relation to this project. So I'm in my in-class project. So I'm in this folder that you may see in this files tab in the bottom right-hand corner. And so if I were to just say, I want a ggsave and I'm going to name it, final plot.png, what would happen is that this final plot.png would save right next to or within the working directory that I'm in. So it would just populate kind of right here next to these data folders, next to these scripts folders, next to my R project. If I wanted to put this in a special folder called like plots, I could either do this new folder thing, which is a point and click option, or remember I could say directory.create in R. And I might want to say, basically, I want a new folder called figures. And if I run this dir.create open parentheses quotation figures line of code, then what I will populate here is a new folder called figures. And so then it would probably be best practice, instead of just kind of dumping a whole bunch of plots in unnamed folders or no folders at all within your project, is to now in your ggsave, in your first argument, which is going to be your file, is going to be quotation mark figures / and then you can name it whatever, finalplot.png. And you can go ahead, well, I guess, so there's going to be a second argument. I'm pretty sure what ggsave does is it will actually, if you don't specify which plot you want to save, it will just save the last plot that you've created, which is nice, but can sort of get you in trouble if you don't specify. So yeah, if I also explore inside these arguments, I have file name is the first argument, so file name to create on a disk, and then plot equals which plot do you want to save? And it says defaults to last plot displayed. So it should auto save the plot that I just ran, but sometimes it's good to really specify, in case you're jumping around in your code, that I want a plot equals final plot. And when I run this line of code, I get a little notice that it's saving an image and it tells me the dimensions of the image. And I could go check inside my figures folder and see that it has in fact saved finalplot.png. I'll note that it sort of defaults to a certain image dimension, but you can specify these sorts of things. So there are a few, you can check out the different arguments inside ggsave with this tab button or with the help button, remember, but you might want to say width equals 6, for instance, and this lets you kind of play around with what kind of dimensions you want. And I'm choosing 6 and 4 in part because these are slightly standard, but I can also specify. There are different units in which you can specify sizes. And so I want to make sure I'm saying I'm specifying my units in equals quotation inches, IN, which stands for inches. So I can go ahead and run the same line of code. It will overwrite my final plot. I want to open it, but I don't think my screen sharing is set up for this. So you can open yours and see if it works. And so that's just a little bit about saving. And last, I just want to introduce, because it's kind of fun, this next library or a series of functions in the package plotly, so plotly. So if you install, so I sort of forgot this, but just like we did with cowplot, if you do the install.packages and then inside quotation marks plotly, you'll then be able to load the plotly library into your R session. And then it's a pretty straightforward, I think the function is also just plotly. And what you do here is inside plotly, you can just give it one argument, which could be an old, a plot that you've made. So we can call upon the iris.plot that we've already made. And it doesn't like this. Why not? Okay, because plotly is not actually the function I wanted. I wanted the function ggplotly because I want to say specifically that here is the ggplot object that I want to sort of integrate with this plotly feature. And so then I can do ggplotly on my iris.plot. And what happens here is it opens up a tab that we haven't really explored yet. And this is the viewer tab. And for any of you who have been asked to knit things into HTML before, maybe for a stats class or something where you've had to turn in something in an R Markdown document, this is something we'll be talking about at the very end of the quarter. But what this viewer does is usually provide you the view of something as it's visible in HTML, which means that it's not like this static PDF or PNG image, but it can actually be interactive. So at a glance, this plot looks just like we had seen it previously, but what Plotly does is that it makes the plot interactive. So you can hover or click over certain points and get information about it. You can even filter, I think, out by, so I'd clicked on this Setosa color and it actually eliminated those points from the plot. So you can sort of slowly integrate and reintegrate different factors or whatever you've sort of colored or grouped by within the plot. With much more advanced plots, it might be really useful to be able to like pan or to zoom in or to zoom out or to cut. And you can also download as a PNG. So these can be really fun if you are creating some sort of interactive HTML document. As you become more and more expert programmers, you might eventually get into capabilities that R offers, which would be making different little apps to interact with your data on a website. Or even if you're just exploring your data and you think it would be really cool to be able to pull out specific points or explore it in a little more detail, Plotly is one of many ways to do this, but it's really nice because it pretty much wraps right around a ggplot and allows you to explore it in a pretty user-friendly way. So that's all I have for today, and I will see you guys in class.